Hello. I thought I would do another puzzle. Thought I would do another Sudoku. I sought this one out. It's another puzzle by this creator, GDC. And I sought out one of his or hers puzzles specifically because I just did a GDC puzzle last week involving the zipper line. This one's called Zip-a-Dee-Doo-Dah. And he or she commented on the video, and it made me happy. So I thought I would see what else this guy has. So let's go over the rules, and then let's look at the puzzle. The rules are as follows. It says normal Sudoku rules apply. Digits in equal distance from the center of the lavender zipper line must sum to the digit in the middle of that line. Digits on the marked diagonals may not repeat. Cool. So with that, we should start the puzzle. The last thing to say here is that I found this puzzle through Cracking the Cryptic, although I was searching out from the creator, and the title of their video on this puzzle said it was a little bit easy, which maybe we can tell from the 17,000 solvers. But now we have the puzzle, and we get to think about it. So I've done a few of GDC zipper line puzzles. The idea, at least of the zipper line, is that each of these lines is a odd length, which means it has a center cell, and digits in equal distance from that center cell need to sum to it. So if this was a 9, then maybe these two would be 4 and 5. They would sum to 9. But, yes, so that's the one rule we have. We have the lavender zipper lines. Second rule is that digits on the marked diagonals may not repeat. So I think what that means is that these digits here need to be 1 through 9, and then these digits here need to be 1 through 9, because there are 9 cells along the diagonal. And with that, I think we have all of the rules that we are allowed to use in solving this puzzle. And I have a couple of ideas for places to start, because I have played a couple of the puzzle with the zipper line. So some things that I know about zipper lines is that when the highest number must go in the center. So, for example, would it be possible to put a 9 here? 9 is the highest number we could use, but it wouldn't be possible to put it on any cell except for the center cell of the zipper line, because of the fact that it would need to add with its neighbor to make this with its counterpart. So if this was a 9, maybe this would be a 1 or a 2, but then we'd be left with a number greater than 9 here. And what that tells us is that in this region, there needs to be a 9 along this diagonal. Oop, there needs to be a line 9 along this diagonal. And now we know that none of these 3 can be a 9. In fact, we can do the same thing here. In this cell, we need to place a 9. In this region, we need to place a 9. It can't go on any of the extremities of the lavender zipper lines. It can't go in the middle here because this is along the diagonal, so that means the 9 on this diagonal must go here or here. Okay. Now, maybe I should continue to fill in where 9s can and can't go. So where does a 9 have to go in this region? Well, it's not allowed to go on these like extremities of the lavender line. Can't go on this diagonal, this teal diagonal, which means that the 9 in this region needs to go here. So we've made a little bit of progress with the 9s. What about on this zipper line? This is the center point. We're not allowed to place a 9 on the extremities anywhere, which means that the 9 needs to go in one of these 3, except you can't be a 9, so now I know that one of you 2 is a 9. And just like that, I think we've done most of what we can do. I could do this one too. The 9 isn't allowed to go down here. It's not allowed to go on the zipper line at all, or the diagonal, so that means the 9 must go up here. So we're 3 minutes in, and we have done some things with the large numbers. I now want to move on to 8. I want to continue to work with the large numbers, but I have to figure out how best to do that. So something is that I think these two need to be a 7 and an 8, if I'm not wrong. Maybe I'm wrong. Let me think. Why would that be? Why did I just point at those two and scream out what I thought. Well, the largest number that lives on this line needs to live in the middle. Somewhere in this cell, I need to place a 7 and an 8. If I put an 8, okay, so it's not true that these need to be. If I put an 8 here, I could have a 7 and a 1. But I do think that the 8, which is the largest cell in this region, needs to go on one of these two, because we're no longer allowed to put it on the extremities of the lavender line. I found a new word, extremities, and I'm going to use it to death. But all right, now that we aren't allowed to have an 8 on this diagonal anymore, we aren't allowed to have an 8 on this diagonal, and what that means is that the 8 must appear in this region on one of these extremities. One of you must be an 8. And since that's the case, you, the corner, the center of the lavender zipper line, must be a number that is greater than 8, which means you must be 9. Nice. We got another 9. We know that an 8 goes here and here, which means the 8 can't go anywhere. There. Now an 8 definitely doesn't go on the diagonal, and neither does a 1, by the way. So there needs to be an 8 and a 1. Oop, 8 and a 1 somewhere there. Yes, yes. That was all good. That was all great. Huh. So now we're 6-ish minutes in, kind of at a loss for what to do next. Did I say that you were allowed to be a 1? You're not allowed to be a 1. Kind of at a loss for what to do next. The largest digit that lives on this line needs to be in the center. It's not possible for an 8 to live on this line. It's not possible for a 9 to live on this line. I think the center needs to be a 7. And that pushes the 8 and the 9 out here and here. Now you two are sort of locked together. There's definitely an 8 and definitely a 9 in one of these two cells. Definitely, definitely. You guys must sum up to 7. In fact, you two are numbers that can't repeat and sum up to 7, but we sort of know that numbers can't repeat and sum up to 7. We're not allowed to have a 7, an 8, or a 9 on this diagonal. And the thing about this diagonal is that it goes through these points. So this number needs to be less than 6. Here, the center of the lavender zipper line needs to be less than 6. 6 or below. And the same is true down here. Out here, we're going to have 7, 8, and 9. This is true for both of them. I'm kind of running fast, but I'm hoping my explanations make sense. Yeah, there needs to be a 7, 8, and 9 somewhere in this region. Can't be here, which is, again, and if it can't be here, then this needs to be less than 7, which means all of these need to be less than 7, which means the 7, 8, and 9 must go there. Must go there. Now, the maximum is going to be 6. You need to be a 6. And we're going to have 5 and 1, 4 and 2. These are things that sum to 6. And then we need 3 and 3. I think the 3 and the 3 need to go here because we would be prevented from putting a 3 on any of those cells. But I think we've just made oceans of progress so far. Cool. So, now what? Now we're not allowed to have a 7, an 8, a 9, or a 6 at this point, which means this needs to be bounded from 5 or below. excuse me, this needs to be the number 5 or below. It needs to be bounded from above by 5. We're 9 minutes into the puzzle. This one is going pretty fast, but I think we have enough information to say that these numbers here definitely need to be 7, 8, and 9, because they need to appear somewhere in this region. They can't appear on the zipper line, and they can't appear on the diagonal, which is a subset of the zipper line. But you guys are now kind of all locked together. And now you need to be the numbers 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. The maximum number needs to go with the corner. So you need to be a 5. I'm not allowed to have a 3 on this diagonal anywhere. So this means one of you two needs to be a 3, and then one of you two will need to be a 2, because we need, if this cell is a 3, then this cell is an equal distance from the 5, the center point. So you will need to be a 2. But we do not know where. Also in this big square here, we're going to need a 1 and a 4, but we do not know where those go. So there's also going to be a 1 and a 4 in there someplace. I've highlighted these cells as all locked together, but in reality, these cells are the ones that are locked together. Anyway, now we can do this. We can say that a 2 definitely goes on this diagonal, right? 2 definitely goes on this diagonal, which means that this one is not allowed to be 2. This is kind of fun. You're not allowed to be a 2, which means you're allowed to be a 1, you're not allowed to be a 2. You're not allowed to be a 3. You can be a 4 or a 5. But you're not allowed to be a 5 because it's encoded in the puzzle. That's all right. You're only allowed to be a 1 or a 4. The 2 must go up here. These 3 cells together must contain a 1, 2, and a 4. Interesting. Very, very interesting. But now you must either be a 5 or a 2. So you need to add to that number. Maybe what I should have done is I should have used the small numbers, because I don't think I want to fill in everything. But you must be a 1 or a 4, did we say? You must be a 2 or a 5. The other numbers. Cool. Lots of progress. Lots of progress. I want to continue to go on this. I don't know where to go next. Let's see. This can be... We can't have a 7 along the diagonal. Let me think for a second about how that would work. We can't have a 7 along the diagonal because of this 7, which means that a 7 needs to go on one of these extremities. And that means that the number in the corner needs to be greater than 7. There's only one number that's greater than 7 and less than 9, and it's 8. So you must be an 8. And now you are not allowed to be an 8. You're not allowed to be an 8 either. An 8 must go up here, which means an 8 cannot go here. If an 8 can't go here, then a 1 can't go here. Just saying. I mean, just got to continue, got to follow. I'm going to do all the... When you start something, at least in Sudoku, you should take it all the way to the end. Otherwise, you're going to forget about it, and yeah. Well, let's see. What can we do? Huh. I mean, we're slowly filling up these regions, right? Like, what's going to happen is, in 5 minutes, this is all going to be numbers, and this is all going to be numbers, or something. But then my question is, what do I do with these regions? What am I going to do with those regions? Because we don't have any progress or any ideas of what to do in these. I don't know what you would call these, the top, bottom, left, and right regions. All right. balloons are flying in my video. That was an accident. It's not like I have a balloons button here. We've sort of filled in this whole diagonal. I want to see if we can fill in the rest of this diagonal. So what is not allowed to go on this line anywhere? What's not allowed to go on this line anywhere? A 4 isn't allowed to go on the line anywhere. The reason why is because if this was a 4, then U would also need to be a 4. Which means that our 4 definitely goes up here. 4 is not allowed on the lavender zipper line because it's half of the corner value. And now none of you guys can be 4, which means a 4 and a 5 definitely go somewhere on this line. Except for one thing, you guys can't be 5, which means you guys can't be 4. Yep. This all checks out. I think. Where does the 3 have to go in this region? Well, the only place that a 3 can go in this region is here, which means that 3s aren't allowed in this column. They're also not allowed in these 2 rows, which means that 3 would need to go here or here. If this was a 3, this would have to be a 6. I feel like that's sort of allowed. I realize actually that we're sort of close to filling in what would need to go here and here. You're not allowed to be a 4 and a 3. It means a 4 and a 3 need to appear out here someplace. But if we could rule out like a 6, that would be the best case scenario for us. So we know that a 3 needs to go here or here. We're 16 minutes in. I want to see how fast we could do this. I want to see how fast we can do this. I guess I'm not like stepping on it. Maybe I said this at the beginning of the video. I just made soup and I'm waiting for it to cool. I guess maybe I didn't say that, but I've got maybe 20 more minutes. My girlfriend comes home. 20 more minutes, the soup is going to be at a normal temperature, and it's going to be an awesome night. And that means I've got about 20 more minutes to do Sudoku. So, all right, let me do some thinking. Okay. The only things left. We need to put a 5 on this line someplace. We need to put a 5 and a 3. So like 5 can't go here and here. So like where would the 5 need to go? We could put a 5 here, right? If the 5 was here, then a 3 would need to go here. If a 5 was here, then the 3 would need to go here. 3s are not allowed here and here, which means that 3s are not allowed here and here. 3s are not allowed here and here. What did I just say? 3s are not allowed here and here, which means 5s are not allowed here or here. That is awesome. Okay, cool. We just started with a mass blob of numbers, but we worked it all down to the 5 must go in this row. There must be a 5 in this row, and there must be a 3 in this column. That was very cool. I like that. But we're not allowed to have a 5 or a 3 here. We're not allowed to have a 5 or a 3 here. We're also not allowed to have a 5 down here. I don't think. I think I said something before about how the 5 absolutely definitely went in one of these 4 squares for some reason. None of you are allowed to be. How did I guarantee that the 5 was on this line? I want to double check my... Probably what I did was I guaranteed that a 4 needed to be on it in some way. 4 is not allowed to be on the teal line, which means the 4 needs to be on the lavender line. And then the 5 needs to be on the lavender line. But the deal is that we need to put a 5 on this diagonal someplace. I can't put it anywhere down here because of the fact that I know that the 5 doesn't go on the diagonal. And I can't put it up here because of the fact that I know that the 5 doesn't go on the diagonal. What that means is that one of these diagonals, either you or you, must be a 5. One of you must be a 5. And by its complement, like, one of you must be a 2. So there must be a 2 here or here. This means that a 2 is not allowed on this diagonal. 2 must go on the off diagonal. 2 and 7 must go on the off diagonal. And now I'm going to make things even muddier. I'm going to add all the 2s and all the 7s. And then what needs to go here and here? Maybe I can delete all this, all these numbers later. But what needs to go here and here? 1 and 3. Except you're not allowed to be a 3. So with that, you are definitely a 1, and you are definitely a 3. We've added some more numbers to this puzzle. I lied. I totally lied. What needs to go on the off diagonal is not 1 and 3. Let's back up here for a second. What needs to go on the off diagonal? Let's figure this out for real. There's 2 numbers that are missing. Here we have 6 squares, and we should have 6 numbers on that. We've got a 1 on it, 2 on it, 4 on it, 5 on it, 6 on it, 7 and 8. 6 and 3 were the numbers that I should have been thinking of. You must be a 6 and a 3. You must be a 6. You must be a 3. Sorry, that was silly behavior. I said 1 and 3 originally, but we now know that you need to be a 6 and you need to be a 3, and we know this because of the fact that we were able to get most every other number on the diagonal. So what number is missing on this diagonal? It's 1, it looks like. 1, that way we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're definitely a 1. And now you are an equal distance. You add to 8, so you must be a 7. All right. You are not allowed to be a 1 anymore. And if you're not allowed to be a 1, then you can't be a 4. But you're also not allowed to be a 1, which means you can't be a 4. Narrowing things down a bit, you need to be a 2 and you need to be a 3. And now you're not allowed to be a 2. You're not allowed to be a 2, which means you're not allowed to be a 3. So we know that a 1 and a 4 definitely goes here and here somehow. You're not allowed to be a 6 or a 7. You're just not allowed to be a 7, and you're just not allowed to be a 6. Yeah, so we've made some progress narrowing things down. This needs to be 6, 7, 8. I don't think we can narrow down any further. What are the other numbers that I'm missing in this region? No, I should keep going. So you must be a 9. Now you two need to be 7 and 8. You must be a 4, which means you must be a 2 because of the lavender line rule. And then I think we're going to have a real opportunity to cut this down. But now you need to be a 1. I think we just like unlocked it. We've added like 10 more squares here in just a minute. So you're not allowed to be a 4, which means you're not allowed to be a 5. You're not allowed to be a 2, which means you're not allowed to be a 7. You are also not allowed to be a 2. Neither of you two can be 2s. What that means is that neither of you two can be 7s. Neither of you two can be 4s. And what that means is that neither of you two can be 5s. And that may wrap it up. I think we are left with the following set of numbers. Am I right about this? You can be a 1 or a 2, which means you can be a 7, 8. You can be a 1, 2, or 8, which means you can be a 1, 7, and 8. So there's actually only one cell in this region where a 5 can go. And only one cell in this region where a 4 can go. So you must be a 5. Now you must be a 4. That was some good process of elimination. And now the 1 and the 2, the 7 and the 8 definitely must go here and here and here and here, someplace. All right, what's missing on this line? We need a 1. We need a 1 and a 5. 5 can't go here. 5 must go here. 1 must go here. All right, and now you can't be a 1. You can't be a 1, which means you can't be an 8. And we have made tons of progress. I guess I'm leaving the colors on. Let's leave the colors on for just one more second. It takes too much time adding and removing colors. But we are 24 minutes in, and just like I said, I think we've basically filled up these squares and made no progress on the horizontal and vertical, which is just kind of fun. This is a great puzzle. I also said this, I think, at the beginning, but I did another puzzle by GDC, and I would have to think of its name. I've done 2, and I filmed one of them. So I remember a Zip from the Devil's Cup. That was a fun puzzle to do, but I didn't get the chance to film it. This one, not this one, the other one that I filmed, a GDC, him or her, responded to the video, and it made me happy, and it made me want to dig up some more by him or her. So, great puzzle. I'm enjoying it again. Cool. I know I'm missing a 3 and a 5 up there. I'm also missing a 2 and a 6. Those are the other numbers that add to. I'm missing a 2 somewhere from this cell, somewhere from this region. Where are my 2s? So I can't put a 2 here. 2 must go here or here. All right about that? And if a 2 goes here or here, that means a 6 must go here or here. But the thing about that is that this can't be a 6. So you must be my 6, and now because of the lavender line, you must be my 2, you must be my 5, and you must be my 3. Awesome. Rock and roll. I'm missing a couple numbers from this row. I think we're going to break into this cell. Missing a couple numbers from this row. So for example, I'm missing a 1, but I definitely can't put the 1 here. And I'm missing a 2, and I definitely can't put the 2 here. The reason for this is that if I put the 2 here, then there's nothing that I could use to add up to 2 except for 1 and 1. So what I'm hearing is that you 2 are probably my 1 and my 2. You're definitely my 1 and my 2. And then you're not a 1, 2, 3, 4, 5. You could be a 6, an 8, or a 9. You're allowed to be a 6, an 8, or a 9. You're allowed to be a 6, an 8, or a 9. Let's think about what happens if this is a 6. Why would we think about that? Let's think about what happens. I want to see if we can actually eliminate one of these because of the 2 options here. If you were a 9 and you were a 1, you would need to be an 8. That's actually allowed. So that was a failure. If you were an 8 and you were a 1, you would have to be a 7, which is not allowed. If you were an 8 and you were a 2, then you would have to be a 6, which is not allowed, which means I think it is not possible for you to be 8. You must be a 6 or a 9. If you were a 6 and you were a 1, then you would need to be a 5, which is not allowed. If you were a 6 and you were a 2, then you would have to be a 4. Two are locked together. So I think that anything goes when it comes to these cells, but we should figure out what my 2 options here are. If you're a 6 and you're a 1, then actually if you're a 6, it's really like all of these cells are locked together. If you're a 6, then you must be a 2 and you must be a 4. If you're a 9, then you must be a 1. Then you must be a 1, and you must be an 8. So there's some behavior going on with all of these. All of these somehow, determining any one of these determines what all of these are. Cool. Cool. All right. Can we get back to the rest of the puzzle? I need 1, 2, 3, 4, 5, 6, 7, an 8 and a 9. Not super helpful. But we're close. I mean, I need to do something with the rest of this line. How can I add to 5? I can use a 2 and a 3, a 4 and a 1. But I'm not allowed to put a 2 or a 3 in this diagonal, in this vertical. Right? Which means you're not allowed to be a 2 or a 3. The other options are a 4 and a 1. Because you need to be a number less than 5. You can't be 4. You need to be 1. Which means you need to be 4. Now you're not allowed to be a 1. You need to be our 2. Which means you need to be our 7. You need to be our 1 so that you can be our 8. And now, I feel like I keep saying and now. You are definitely an 8 and a 9. If you're definitely an 8 and a 9, neither of you can be an 8 and a 9. So you're not allowed to be an 8 and a 9. You need to be a 6. That means you need to be a 7. And now you need to be a 9. We just worked through what happens when that needs to be a 9. You need to be a 9. But if you're a 9, can you be 1? If you can be 1, then you can be 8. Yes. Can you be 2? You cannot be 2. So you need to be a 1. You need to be an 8. You need to be a 2. This is such a fun puzzle. I really do like the zipper line concept. Conceptually, it's very simple. It's something that you could put on like a, I mean, I don't know about hard Sudoku, but like it's something that you could put on a third grader's homework. Like, you know, there's a 6 in the middle, like a 1, 4, and 3, and you tell the whatever I said, third grader, like fill in the other numbers so that, you know, distance, like numbers in equal distance add to the center. Like it's very easy conceptually to get. But what happens is you can get, I guess, puzzles where you have very few zipper lines, and the zipper line rule is very, very easy, and the whole thing is solvable. Like this one. So I'm a big fan. 1, 2, 3. We need a 4 someplace. One of you two is going to be a 4. 5, 6, 7. One of you two needs to be a 7. That's what's missing. But that's probably not the place. I keep doing things and saying to myself, that's probably not the place to start. Maybe this is the place to start. Maybe this is the place to start. I need a 7 somewhere on this vertical, but it's not allowed to go here, so you need to be a 7. You need to be a 7 like that. Now I need a 1, 2, 3, 4, 5, 6. I need a 6 somewhere on the vertical. You need to be my 6. Could we do that somehow again here? 1. I need a 2, but I don't know where the 2 goes on this vertical. 1, 2, 3 is my other thing that's missing. So you need to be a 2 and a 3. But no fun. No fun. Doesn't tell me what it is. Let's continue to work around. Is there something that needs to go down here? 1, 2, 3. One of you two needs to be a 4. 5, 6, 7. One of you needs to be an 8. But only one of you can be an 8 as it happens. So you need to be an 8. Okay, now you need to be a 9, which means you need to be an 8. We filled in the diagonal. Something I've learned about this site is that there's confetti hiding in it somewhere. I don't think we've gotten there yet, but at some point I'm going to fill in a cell and confetti is going to appear all over the screen. I'm excited for that. I feel like we've narrowed it down to very few options for the confetti. Let's see. There needs to be, in this row, this is definitely not where I'm supposed to start. 1, 2, 3. 5 isn't allowed to go here. 1 isn't allowed to go here. So one of you two are a 1, right? One of you two are a 5, right? And then the other number that I'm missing is a 9. You need to be my 9. So you're a 9, you're a 5, you're a 1. We're really basically at the end. What else do I need? 1, I'm missing a 2. So like so you need to be 2. 1, 2, 3, 4, 5, 6, and 7 are what I'm missing. So there needs to be here and here. There needs to. Can I do it this? No, I'm not going to do it that way. I'm trying to get better at using the Sudoku pad. 6 and 7 definitely go there and there. Let's just keep working around though. In this row, 1, 2, I need a 3. 3 needs to go here or here. 4, I need a 5. That 5 needs to go here, right? And then I need a 6. That's the other one that I'm missing, and that 6 needs to go here or here. We're just filling it in. At this point, it's like it's easier to do, I think, but we're just gotta race. 1, 2, 3, 4, 5. There's a 5 missing. That 5 needs to go here or here. 6, 7, 8. There's an 8 missing. That 8 needs to go here or here. This means you are a 9. You're a 9, which means you're a 9. Now I can start filling in things on this side. 1, 2, 3, 4, 5. I need a 6. 6 can't go here. 6 can only go here or here. I also need a 7 and 8. 7, 8, 9 can't go here, so you need to be our 6. And now you need to be a 7 or an 8, as I believe what that shakes out to be. 7 or an 8. 7 or an 8, not a 6. You need to be a 7 or an 8. 1, I need a 2 in this region someplace. Don't worry about that. I need a 3 in this region someplace. Don't worry about that. I need a 4, 5, 6. Okay, not very helpful. I need a 1 somewhere. 1, 2, 3, 4. I need a 4. 4 can only go here or here. I need a 5. 5. Maybe what I should have just done was like, it needs to be a 7. That 7 needs to go here or here. But we sort of knew that already. Anyway, now I feel like I was doing the wrong thing, which is I was just hopping around, trying to fill in everything into the corners as I possibly could, and hoping that the Sudoku pad tells me when it's all done. But that was definitely the wrong approach. I think I should try to use some reasoning. Like, where would a 1 need to go in this cell? That 1 would either need to go here or here, right? Which means the 6 needs to go here or here too. You can't be a 6. You need to be a 1, and you need to be a 6. So now you need to be a 3, and you need to be a 6. You need to be a 7, and you need to be a 6. Oh boy. All right, what we're missing in this region? 4 and 3. There must be a 4 and a 3 along this in here and here. Can I just do it like this? That would be kind of fun. Yes, I can. You need to be a 4. You need to be a 4. You need to be a 3. Now, you need to be a 4. You need to be a 3. You need to be a 2. You don't really need to be anything. You need to be a 7, and you need to be a 4. Was I lying about the confetti? I think there's confetti in here someplace. There needs to be, okay, 1, 2. 2 is what's missing, right? You need to be a 2. There needs to be a 1 in this region someplace. That 1 needs to go here. 2, 3. There needs to be a 3. That 3 needs to go here. Now I think it's safe to say that you're a 7. Now I think it's safe to say that you're an 8. You're a 7. 1, 2, 3, 4, 5, 6, 7, 8. 5. There's no confetti. I'm gonna have to go back and rewatch the video. Maybe it appeared earlier. That was a lot of fun. Thank you to GDC for I don't know, the gentle encouragement and making 2 awesome puzzles. This one was called Zip-a-Dee-Doo-Dah, and if you're watching this, you should go and play it. I am delighted to be the 16,884th person to do it, and I will give it a little like. All right, see you next time.